In this lesson, we'll talk more about 3D pocket rest machining. After completing this lesson, you'll be able to create a 3D pocket rest toolpath and modify toolpath parameters to adjust cutting resolution. For this next lesson, let's start with a supplied file, Open Pocket Rest Machining. This is a file that we've seen before when we compared a pocket operation to an adaptive operation when we're dealing with open geometry. Now we want to take a look at how we can utilize rest machining in a 3D pocket. To get started, this file has a pocket operation, and I always like to get started by simulating this and navigating to the end of the toolpath. So now we can see exactly what material has been removed and what still is left behind. So now that we know what's been removed and what's been left behind, I'm going to start by right-clicking on Pocket and duplicating it. Then I'll go into the copy and I'll edit. And I'll start by selecting a smaller tool. Utilizing my supplied library, I'm going to drop down to a 3/16 flat end mill and say OK. Then in the geometry section, we're going to utilize rest machining. This is going to be from our previous operations. We're going to machine cusps, and the adjustment offset is set to 0.02. We're going to make sure that the tool in this case is outside the boundary, as we want to make sure that we can get all the way into these fillets. Then inside of our passes section, notice that stock to leave is still set to 0.02. Everything else we're going to leave the same, and we're going to say OK, and we're going to see exactly what material was left behind and what we can actually get to. So you'll notice in this case that this end mill is actually creating a contour that goes around the outside of our part. If we want to restrict that, we can edit the toolpath, go into our geometry section, and change the tool containment to be centered on boundary and say OK. So you'll notice that even with the tool centered on the boundary, it still is able to get outside of that part. If we go to Edit and we set the tool to be contained inside of the boundary and we reduce this offset to 0, this will restrict the tool from going outside of that boundary. You'll notice that it is jumping over these areas, but that's okay because we're not looking at a finishing toolpath at this point. We simply want to remove a little bit more material. Let's take a look at this by simulating it. We're going to step to the next operation. Then we're going to see what the pocketing rest operation does. I'm going to change the material to ceramic and change the color by operation, then rotate this a little bit so maybe it's a little easier to see. And I'll also speed it up so we get a good idea as to what is being removed. So not a ton of material is being removed. So likely what we can do is we can modify this second operation by going in and changing the tool. Instead of using that flat end mill, I'm going to go into tool number 6, the 1/8 inch ball. Then I want to go into my passes and take a look at some of my passing options. So right now our smoothing deviation is 0.0025, which should be fine, and then the maximum roughing step down is 0.025. So that looks pretty good. I'm going to go ahead and say OK, and notice that the step over should be set manually for ball cutters. Do you want to ignore the warning? If we say no, then we want to use the manual step over option to manually set how far the tool can move over in each direction. So right now the maximum step over is 0.025 and the minimum is 0.0025. We can say OK, then allow it to calculate this operation. So you'll notice that now we have a lot more passes on this shape. So what's happening is it's taking this ball end mill because it can match the contour of our part, and it's getting a little bit closer to that final shape. So again, let's simulate, go to the next operation, and then we'll play through speeding this up to get an idea of what that final shape is going to look like. So you can see this tool is small enough that it's starting to dip into those pockets, and it's getting pretty close to that final shape. If we change the transparency of the stock, we can see the underlying shape and the one that we're machining. So this is looking pretty good in terms of a shape. There's still material that's left behind all over the part. And if we want to get even closer, we can modify the parameters by going into Edit, going into Passes, and we can change the stock to leave to something a little bit smaller. For For example, we can go down to 0.01, and that way we're getting closer to that final shape. Let's navigate back to a home view, and let's go ahead and simulate this one more time. However, this time I'm going to simply jump to the end so I can see what that final shape looks like. So now we can get an idea on what the final shape is looking like after we have our original 3D pocket operation, and then we have a 3D pocket rest operation. There's still obviously a lot more to do here in terms of finishing and coming back and clearing out a bit more material. But you should start to see that by utilizing some of these operations, we are able to remove a lot of material quickly by using a large end mill, in this case a 1/2 inch. Then we can come back with either a smaller flat end mill, or in this case we even looked at using a ball end mill to get closer to that final shape. So that way we can come back and we can focus specifically on certain areas like the fillets that wrap around, and then we can take a look at creating 3D toolpaths that allow us to cut the very specific shape of these fillets and blends between certain areas. For right now, we're going to navigate back to a home view, and we're going to go ahead and save our changes before moving on to the next step.